a very good evening, everyone. I, Dr. Parveen Saini, welcome you all on behalf of SSM'D, Organizing Committee and NPL Scientist Community for this 13th lecture under the SSM'D lecture series on the theme Metrology for Science and Society, to be delivered by the Professor Venu Gopal Achanta, Honorable Director, CSIR-NPL. This lecture will be followed by an on-air release of the third issue of the Swadeshi Vigyan Patrika, jointly by Professor T. Ramasami, former Secretary, Ministry of Science and Technology, and Distinguished Professor of Eminence, Anna University, and Professor Venu Gopal Achanta, Director, NPL. Now, before we proceed with the program, I request Dr. Ashutosh Parekh for Mangalacharan Pro. So, Dr. Ashutosh Parekh, please.
Om Vishwani Deva Savitar Duritani Parasuva Yadbhadram Tanna Asuva Om Samani Va Akutihi Samana Hridayani Vaha Samanamastu Vo Mano Yatha Vah Susahasati Om Shanti Shanti Shanti। विज्ञान, संस्कृति और भारतीय परिदृश्य का एक अनुपम संगम है यह स्वदेशी साइंस मूवमेंट ऑफ इंडिया, और निश्चित रूप से अनवरत एक ऐसा प्रयास किया जा रहा है जिसके माध्यम से विज्ञान और भारतीय प्राचीन उस विज्ञान को आज के विज्ञान के साथ जोड़ने का प्रयास किया जा रहा है, जिसके कारण हम अपने भविष्य में भारत को एक विश्व गुरु के रूप में स्थापित होते हुए देख सकते हैं। निश्चित रूप से जब कहा जाता है सा प्रथमा संस्कृति विश्ववारा, तो वह भारतीय संस्कृति ही है। उस भारतीय संस्कृति का वह वैज्ञानिक और तार्किक दृष्टिकोण ही है जिसके कारण से हम कह पाते हैं कि भारत एक ऐसा देश रहा है जिस देश के माध्यम से उसकी संस्कृति के द्वारा, उसके विज्ञान के द्वारा संपूर्ण विश्व आलोकित होता रहा है, और उसी आलोक को संपूर्ण विश्व में फैलाते हुए देखने का एक प्रयास है यह स्वदेशी साइंस मूवमेंट। स्वदेशी विज्ञान आंदोलन के माध्यम से, जिसे विज्ञान भारती के नाम से भी जाना जाता है, यह आज 13वां व्याख्यान, इस व्याख्यान श्रृंखला के अंतर्गत हम सभी एक साथ उपस्थित हैं मेट्रोलॉजी फॉर साइंस एंड सोसाइटी पर व्याख्यान को सुनने के लिए। और मैं डॉक्टर आशुतोष पारेख, हमारे आज के कार्यक्रम के संयोजक डॉक्टर प्रवीण सैनी, प्रिंसिपल साइंटिस्ट CSIR-NPL, और साथ ही आयोजन मंडली के सदस्य डॉक्टर संजय यादव, श्री मधुकर स्वयंभू, डॉक्टर शुभाशीष पंजा, श्री रोशन अग्रवाल, श्री VK गुप्ता, इन सभी की ओर से आप सभी का हार्दिक अभिनंदन एवं स्वागत करता हूं। और साथ ही मैं स्वागत करता हूं आज के हमारे कार्यक्रम के मुख्य वक्ता के रूप में पधारे हुए वरिष्ठ विज्ञानी, जो कि निदेशक हैं CSIR-NPL दिल्ली में, प्रोफेसर वेणु गोपाल अचंता जी का। साथ ही आज के कार्यक्रम में स्वदेशी विज्ञान पत्रिका के तृतीय अंक का भी विमोचन किया जाने वाला है, और उस हेतु विशिष्ट रूप से पधारे हैं डॉक्टर T. रामास्वामी। आपका भी बहुत बहुत हार्दिक अभिनंदन एवं स्वागत है। आप फॉर्मर सेक्रेटरी विज्ञान व तकनीकी मंत्रालय एवं डिस्टिंग्विश्ड प्रोफेसर ऑफ एमिनेंस अन्ना विश्वविद्यालय हैं, और आपके और प्रोफेसर वेणु गोपाल अचंता जी के कर कमलों से स्वदेशी विज्ञान पत्रिका के तृतीय अंक का भी विमोचन आज के कार्यक्रम में होने वाला है। अतः आज एक विशिष्ट कार्यक्रम है, क्योंकि यह एक व्याख्यान के साथ साथ किसी विशिष्ट विषय को प्रस्तुत करने के साथ साथ ऐसे लेखों के संकलन से तैयार होने वाली स्वदेशी विज्ञान पत्रिका के तृतीय अंक को भी हम सभी के सम्मुख लेकर के आने वाला होगा, जिसके माध्यम से, जिसके आने वाले अंकों के माध्यम से भी निश्चित रूप से हम सभी विज्ञान और भारतीय संस्कृति को एक साथ जुड़ता हुआ देख सकेंगे। अतः आज के इस कार्यक्रम में आप सभी का हार्दिक अभिनंदन एवं स्वागत। और मैं अब विनती करता हूं, प्रार्थना करता हूं हमारे कार्यक्रम के अध्यक्ष डॉक्टर डीपी भट्ट सर से, जो कि वरिष्ठ विज्ञानी हैं, पूर्व विभागाध्यक्ष IPRM CSIR NPL हैं और साथ ही विज्ञान भारती के संस्थापक हैं, ऐसे डॉक्टर डीपी भट्ट सर, जो कि अनवरत रूप से विज्ञान की सेवा में लगे हुए हैं और विज्ञान के साथ साथ भारतीय संस्कृति के एक ऐसे प्रचारक के रूप में हैं जो कि लगातार उस भारतीय संस्कृति को विज्ञान के साथ जोड़कर हमें एक नई दिशा प्रदान कर रहे हैं। तो मैं आमंत्रित करना चाहता हूं कार्यक्रम के अध्यक्ष और साथ ही SSM'D के भी अध्यक्ष डॉक्टर डीपी भट्ट सर को कि आप पधारें। आपसे निवेदन है सर कि आप SSM'D के बारे में और साथ ही हमारे आज के अतिथि वक्ता प्रोफेसर वेणु गोपाल अचंता जी के बारे में और साथ ही श्री डॉक्टर टी रामासामी जी के बारे में भी, और साथ ही SSM'D किन उद्देश्यों को लेकर के कार्य कर रही है, उन सभी का एक परिचय आप हम सभी के सम्मुख प्रस्तुत करें। डॉक्टर डीपी भट्ट सर।
नमस्कार, आप लोग सुन रहे हैं मुझे?
जी सर, आपकी आवाज आ रही है सर।
नमस्कार, गुड इवनिंग। संस्कृतनिष्ठ ज्ञानी डॉक्टर आशुतोष पारिक जी के सात्विक श्री गणेश से यहाँ पर एक मंगलमय वातावरण का आगाज हो चुका है। इसी को आगे बढ़ाते हुए मैं चाहता हूं कि आप सब भी आज के इस महत्वपूर्ण मंच को ऊर्जा से भरें। वैध हो सके तो करतल ध्वनि से हमारे मुख्य वक्ता प्रोफेसर वेणु गोपाल अचंता जी का स्वागत करें। जो आज एक आम जन उपयोगी विषय पर उद्बोधन देंगे। इसके साथ ही ये हमारे लिए गौरवशाली क्षण है, गौरवशाली दिन है कि हमारे बीच डॉक्टर टी रामास्वामी, फॉर्मर सेक्रेटरी भारत सरकार, डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी, वो भी मौजूद रहेंगे। अभी तक मुझे स्क्रीन में दिख नहीं रहे, शायद वो ज्वाइन करेंगे शॉर्टली। उनका भी मैं तहे दिल से आज के कार्यक्रम में स्वागत करता हूं। मैंने महत्वपूर्ण कहा इसलिए भी क्योंकि हमारी टीम ने कोरोना त्रासदी कालखंड के बीच सक्रियता का एक ऐसा उदाहरण पेश किया, वह भी अप्रत्याशित चैलेंज के साथ, जो हमने ई लेक्चर सीरीज 2021 शुरू करी फरवरी में और जिसका उद्घाटन माननीय विज्ञान शिक्षा मंत्री उत्तर प्रदेश सरकार श्रीमती नीलिमा कटियार जी के माध्यम से हुआ था। एक साल के भीतर आप लोगों ने 12 संस्करण आयोजित किए हैं। रादर एक साल भी नहीं हुआ, फरवरी से आप काउंटिंग करेंगे तो शायद अभी 12 महीने भी नहीं हुए हैं। तो 12 संस्करण करना ये बहुत अद्भुत बात है, वो भी कोरोना की विपरीत परिस्थितियों में। तो इसलिए मेरा सभी आयोजकों को अंतर्मन से धन्यवाद, आभार। मित्रों, जीवन के रास्ते में हमें कब कौन मिलता है और कहाँ मिलते हैं, उन पर हमारे जीवन का कार्य और कई और चीजें भी निर्धारित होती है। मैं बात कर रहा हूं डॉक्टर वेणुगोपाल जी की। मेरा आपसे कोई पूर्व परिचय नहीं था और ना ही हम कभी पहले मिले थे, लेकिन एक महीने पहले जब मैंने आपको व्याख्यान देने हेतु एक निमंत्रण भेजा, आपने उसका त्वरित जवाब देकर हमारा अनुरोध स्वीकार किया। तत्पश्चात मैं जब आपको एनपीएल में मिला, मिलने के बाद ऐसा लगा जैसे हम एक दूसरे को शायद काम से पहले से ही जानते हैं। एक हमारी पुरानी पुरखों की युक्ति है योगा कर्मेषु कौशलम, यानी दक्षता से किसी भी कार्य के परमोत्कर्ष पर बल देना। आपकी कार्य प्रणाली में मैंने देखा, आपका श्रीमान इस कार्यक्रम में पुनः हार्दिक अभिनंदन। जैसा मुझे आदेश हुआ कि मुझे कुछ सब्जेक्ट के बारे में या फिर थोड़ा संस्था के बारे में बोलना है। As everybody may know, before joining NPL, he is the product of TIFR, an excellent researcher. Did his PhD from Tokyo University also. Electronics and photonics are his favorite subjects. Now, presently, I think he is trying to prepare a roadmap for the quantum leap in the field of metrology for India. Besides being a coordinator of global nanophotonics network of about 10 countries. Metrology, यदि आप उसको हिंदी में कहें मापन, यानी measurement system, it has an inherent and age-old impact on everybody's routine aspect of human life, be it weight, length, mass, temperature, and time. NPL being the NMI of India, many of you may know or may not know, is the sole custodian of the national standards of measurements by the Act of Parliament, and has been playing pivotal role to take its services to mass through patents, copyrights, training, consultancy, technology transfer, etc. I will speak just few lines on time because I always say and believe that if you have contributed on something, then you speak, otherwise don't speak. Because I have bit contributed on time part of it, basically with regard to teleclock, through guiding some MBA student of Banasthali Vidyapeeth, if I remember rightly, from Rajasthan. So there I got something to do with some market analysis done with regard to teleclock. So I have the right to speak on teleclock a bit, because bit I have contributed, though I don't consider myself an expert, as I told Sanjay Aroji already, on metrology. Time, as you may know, is that NPL is the timekeeper of the nation. We have been able to do a series of innovation, rather transformation of innovations from STFS technology, then to teleclock, then to mobile teleclock. Now, when I left NPL, I think now presently they are very much on atomic clock for applications with regard to cyber security, ISRO, etc. With regard to teleclock, basically precise time with nanoseconds accuracy has been the need of the application in time kind of things, which NPL has been servicing the nation for many years for varieties of utilities, say in parliament, railway stations, ISRO, moving vehicles, police patrolling, etc. And a great part of the teleclock technology has been, they have been, or we have been, because I consider myself a part of NPL even now, we have been able to not only license this teleclock technology to several Indian industries, but also we have been able to give it to SASO, Saudi Arabia, I think standard organization, if I'm right. And not only that, NPL, for your kind information, it doesn't strive just to make money. And through teleclock, we have shown to the world, to the nation, that we sometimes even do contribute in societal obligations, say for the deprived nations like Nepal. We have been able to give them the technology for a meager grant, perhaps if I remember rightly, it's 4.5 lakhs we got from the Ministry of External Affairs. And with that, we did a sympathetic favor. NPL did a sympathetic favor to Nepal by giving the technology. And later on, SAARC countries, SAARC also announced that if it's successful in Nepal, and they all will be able to purchase the technology. I do not know the current status. Now, this is all about a little bit on the subjects. More will be dealt with by the director himself. Regarding the forum, as I have been asked to say a few words, स्वदेशी साइंस मूवमेंट ऑफ इंडिया, इसको हम विज्ञान भारती दिल्ली के नाम से भी जानते हैं, एक अखिल भारतीय साइंटिफिक फोरम है जिसका लालन पालन, पालन पोषण व संरक्षण आईआईसी बंगलौर में 1982 से सिकरी कराईकुड़ी और उसके बाद केरल से स्थापित हुआ। प्रारंभिक बातें मैं बता रहा हूं। आज इसका विस्तार फेडरल स्ट्रक्चर नियम के तहत दिल्ली सहित विभिन्न राज्यों में पूरे देश में इस स्तर तक हो चुका है कि संस्था के बारे में शायद ज्यादा बताना जरूरी नहीं है, आप सब लोग जानते हैं। इसके सोशियो साइंटिफिक एस्पेक्ट्स, सोशियो कल्चरल एस्पेक्ट्स, सोशियो स्पिरिचुअल, सोशियो कल्चरल एस्पेक्ट्स यानी बहुत आयामी योगदान पर चर्चा की जाती है। यदा कदा अब हमारी प्रशंसा भी होने लगी है, कभी कभार हमारे पर प्रश्न भी उठने लग गए हैं। हमने प्राचीन ऋषि ज्ञान, आध्यात्मिक ज्ञान व आधुनिक विज्ञान यानी मेटेरियल साइंसेस से जो उत्पन्न संज्ञान, इसको हम संज्ञान कहते हैं भारतीय परिप्रेक्ष्य में, क्योंकि साइंस वर्ड एक्चुअली अंग्रेजी वर्ड है, हैज बीन बोरोड फ्रॉम द वेस्ट। ज्ञान और विज्ञान, आई विल नॉट गो इनटू द डिटेल्स, इन दोनों को मिलाकर के वी वर्कड ऑन संज्ञान, दैट इज द प्रोजेक्टिव नॉलेज। आई विल नॉट गो इनटू द डिटेल्स। इस पर हमने पिछले 25 वर्षों से अविरल कार्य किया और एंशिएंट विजडम की अवेयरनेस से लेकर आधुनिक विज्ञान, इंजीनियरिंग व टेक्नोलॉजी की कड़ी में ग्रामीण विकास, सतत विकास, इनोवेशंस, सामाजिक विकास, सामुदायिक विकास वो आध्यात्मिक क्षेत्र। आध्यात्मिक क्षेत्र जब कहता हूं, कई लोग ये ना सोचें कि हम शुरू में सोचते थे हम लोग पूजा पाठ, नो, इट्स नॉट लाइक दैट। व्हेन आई से आध्यात्मिक कंट्रीब्यूशन, फॉर एग्जांपल वी हैव बीन एबल टू कंट्रीब्यूट टू द उत्तराखंड नेशनल ट्रेजेडी एंड वी डायरेक्टली विजिटेड टू द स्पॉट एंड डिड दैट, जस्ट एन एग्जांपल। सो दैट्स व्हाट आई मीन बाय आध्यात्मिक क्षेत्र में हमने कई राष्ट्रीय अधिवेशन, विज्ञान मेला आदि संपन्न करे। जो एक बात जो मैं हमेशा कहता हूं विज्ञान भारती दिल्ली के बारे में, आई एम रियली प्राउड ऑफ दैट, जो विज्ञान भारती दिल्ली को एक डिस्टिंक्ट करती है और सभी विज्ञान फोरम से इन द कंट्री। दिस हैज बीन माय क्लेम फॉर लास्ट few years I am talking, but nobody has yet said that you are wrong. And that is, we have been consistently working on the bilingual mode. मतलब भारतीय भाषाओं को हमने यूज करके हमने जितने भी कार्यक्रम किए हैं, आई थिंक मोर देन अ डजन और मोर देन अ डजन पब्लिकेशंस and journals, books, including in CSIR's popular Hindi journal, science journal. I think we could publish more than a dozen, and most of them are in the bilingual mode. And now recently we have also started working on the multilingual mode through स्वदेशी विज्ञान पत्रिका। ये भी हमने कोरोना टाइम में स्टार्ट करी और आज इसका तीसरा संस्करण, 2 संस्करण हम कोरोना टाइम में पहले ही रिलीज कर चुके हैं। सो दैट इज अनदर ग्रेट अचीवमेंट ऑफ आवर टीम लेड बाय डॉक्टर रश्मि शर्मा एंड डॉक्टर विकास श्रीवास्तव एज फार एज ई स्वदेशी विज्ञान पत्रिका इज कंसर्न्ड, एंड आई एम वेरी हैप्पी दैट वी विल बी एबल टू रिलीज दैट पत्रिका टुडे। मित्रों, अंततः मैं समय से आगे की सोच रखने वाले बहुत बड़े साइंस लीडर्स, चाहे वो प्रोफेसर के वासु हों, चाहे डॉक्टर टी रामास्वामी हों, इस तरह के समकक्ष अनेकानेक लोगों की बृहत प्रेरणा से ही आज, और सिक्रियंस, क्योंकि मैं सिक्री में था, और सिक्रियंस और एनपीलाइट्स के सहयोग से ही मैं आप लोगों के बीच में आज बैठा हूं या खड़ा हूं और आई एम एबल टू स्पीक ऑन व्हाटएवर आई स्पोक सो फार। डॉक्टर रामास्वामी जी अभी मौजूद है नहीं है, मैं चाह रहा था उनके सामने ही उनके बारे में कुछ बताया जाए, हालांकि सामने प्रशंसा करना उचित नहीं लगता है, तो मुझे लगता नहीं कि अभी आए हैं और मेरा भी समय ज्यादा हो रहा है। उनके बारे में मैं अभी बोलना, इसको अभी अपने को कंट्रोल कर रहा हूँ। आई थिंक he has not yet come. Has he come?
He's in the yes.
Oh, so nice of you, sir. If he is there, because I love to speak when he is there, but unfortunately I was unable to see him. About Dr. Ramasami, his gracious presence today happened just in the last minute. You may wonder, or even I also wondered, how relevant and appropriate it is for SSMD and NPL on 4th December. That is the birthday of our great founder, Director Dr. K.S. Krishnan sir. And this also I came to, as I reminded, came to know only through Dr. Ramasami for a kind information. I did not know. Even I knew, means I had no idea about that. So point is here that Dr. T. Ramasami, again, he happens to be the chairman of Dr. KSK Memorial Trust. So choosing this day has never been our planning, which Professor Venu Gopal ji alone will agree with me because he knows that we have not planned for the day. So I consider it's a godly decision for all of us that we are conducting this event on this memorial, rather historic day, when we have the birthday of Professor K.S. Krishnan today. So that way I consider it is I will not use the word historic. Everybody says historic. It's a godly day. I will call it as really a godly day for all of us. Let everybody be blessed by that because it was not at all our decision to organize the things on 4th December. So with that, again, it's a godly welcome. I consider myself too small to welcome Dr. T. Ramasamy. It's a godly welcome to you, sir, who for many is an icon as a technologist, come great scientist, leader in the areas of chemical technology, leather technology, IPR leveraging, science policy making. But for me, individually, he is a perfect citizen, a complete human being, embedded with an integrated personality, and a very, very, very simple man, and one of the true lovers of SSMD. Being the fellow of major science academies both in India and abroad, having bestowed with all the top awards, Padma Shri, Padma Bhushan, Sansaru Bhatnagar Award, he decided to become our life fellow, first life fellow rather, with my just 5 minutes meeting, first meeting with him in CLRI long back. So he always takes decisions from the heart, and it's always wonderful to have him in the midst. Whosoever knows him, had an interaction with him, he or she only will talk what I have already talked about him. I think I will not take much time now with these few words. Rather, I have spoken more. Now it's over to Dr. Ashutosh Parekh and rather to Dr. Sanjay Yadav to please do his part in the function. Thank you very much.
Thank you, Dr. Bhatt. It's a great pleasure in the presence of our mentor and Professor Ramaswamy. By his blessings, we are all here. He's a great leader and he has given a lot of blessings to scientific community. It is always pleasure to have him, and this is the second occasion that I am attending this lecture, morning lecture that Professor Sood has given under his guidance that about the foundation day, this birth anniversary of Dr. Krishnan, our founder director. And now it is my privilege to say a few words as I have been asked to do as a member of the SSM'D Executive Council. Professor Venu Gopal Achanta has recently taken over as a directorship of NPL, and we are working with him. And now, for just for the sake of introduction, let me read a few lines about his biodata. He obtained his doctorate degree in PhD in physics from the most prestigious institute of India, that is TIFR, Mumbai, and further obtained another doctorate degree, which is a distinct qualification, another doctorate degree degree of PhD in electronics from Tokyo University, Japan. So he has 2 PhD degree to his credit. He worked as a NEDO Fellow at FESTA Laboratory, Japan, and JST Fellow in NEC Corporation, Japan during 2000 to 2004. He joined TIFR as faculty in 2004 and raised to the level of professor in 2018. His research initiatives are nanophotonics and planar architecture of classical and quantum information processing. He has more than 150 publications in national and international journals of repute. He is on the editorial board of various scientific journals. To name few are Scientific Reports and associate editor of Frontier in Physics and Encyclopedia of Applied Physics. He is an honorary fellow of Metrology Society of India. Recently has been conferred this honorary fellow of the Metrology Society of India and senior member of IEEE and member of OSA. He is Executive Council member of Optical Society of India and Vice Chair of IEEE Photonics Mumbai chapter. He is the Indian coordinator of Global Nanophotonics Network, a consortium of university from 10 countries: Australia, China, Japan, Philippines, Singapore, South Korea, Taiwan, and UK and USA. So that way his contribution is enormous to the scientific community. His main research interests are basically in planar architect and information processing based on combination of metal dielectric and all dielectric metamaterials and photonic structure, broadband metamaterials, plasmonics, and plasmon mediated modulation of material properties. He has handled under his stewardship several brilliant projects, mega project, I will say around 16 crore. He has led that project in various capacities. 3 projects in TFIR around 900 crore, and some other project, 9 other funded project, NIST, Japan, UK, IERE, Swedish Research Council, and also DST project of 7 crore. Dr. Venugopal has mentored many students for their PhD degree. If I'm not wrong, around dozen student has got PhD under his guidance. It is a high time that India as a nation must work together to strengthen the quality infrastructure of India for a nice economic growth at national and international level. Dwelling on his vision, Dr. Venu Gopal is drawing roadmap for the quantum leap in the field of metrology, as Dr. Bhatt has pointed out, and is going to play a lead role in this direction. We are eagerly waiting, sir, your lecture on this topic of metrology and society. Thank you, sir.
So thank you. Now we request Professor Venu Gopal to begin with his lecture. Sir, please.
Thank you. Thank you. Yes, and then before starting, I just want to acknowledge all NPL staff, especially the 6 DU heads. Dr. Sanjay Yadav, thank you very much. And even before that, like I should thank Dr. Bhatt for giving me this opportunity to talk in SSM'D. Right? So yes, as I as already announced, like so I'll be talking about metrology for science and society. This is not my area of interest or area where I worked on. So I learned whatever I am going to present from people being acknowledged here, the NPL staff themselves. So significance of this year is this is 75th year of independence, Azadi Ka Amrit Mahotsav. This is also happens to be the 80th year of CSIR, Council for Scientific and Industrial Research. And for NPL, so this is our 75th year also. So NPL Foundation Day is 4th January 1947. So we are a little older than the India itself, independent India itself. Right. And as Dr. Bhatt already said, like, so today is Dr. K.S. Krishnan's birthday. So that's the reason, like, I chose the topic to talk about metrology, though it is not my forte. Right. So what I'll talk about is just to be part in the talk, like, so to feel myself at ease. So I'll talk briefly about my own work, and then I'll go to metrology. Some historical facts, and then go to new definitions of this international system of units. And because of these new definitions, like, so the role of science has increased. So we need scientists to set up these things. And then as an NMI, the National Metrology Institutes, NPL has a role in setting up these things, as well as addressing the societal needs. So I'll briefly touch upon these things before summarizing the importance of metrology in our daily life. Right. So about my own work, we talk about classification of materials. So we talk about the response of materials to electromagnetic fields. So you have epsilon, the permittivity and permeability, the magnetic permeability of the medium. So we talk about whether epsilon is positive or negative, or mu is positive or negative. So depending on that, so we can classify materials into 4 different quadrants if we plot epsilon and the mu on the y-axis. So in the third quadrant of this, like, we see these negative epsilon materials, negative dielectric constant materials, or the metals or the plasma. And in the first quadrant, we have the naturally existing materials, the dielectrics, the positive index materials, which we see around us. And in the fourth quadrant, we see these mu negative materials. Epsilon is positive here. So in the second quadrant, we have both epsilon and mu, both are positive. So here we have the structured magnets and magnetic materials, and ferrites show these epsilon positive and mu negative. So initially, the interesting point came out that, like, this third quadrant where both epsilon and mu are negative. So these are the left-handed materials. Whatever we studied so far in classical textbooks and all that, like the Doppler effect and among others, like, so Snell's law, for example. So these all are for the positive index materials. So the exact opposite happens. Inverse Doppler effect and the Snell's law, like bending, instead of bending in one direction, the bending will be in the opposite direction, happens if we have negative index materials. So these do not exist in nature. So they were called negative index materials or left-handed materials and metamaterials, because they do not exist in nature. However, over the last 15 to 20 years, people started developing new materials, designing new materials, combining the traditional metals and insulators, the conductors and insulators, or metals and dielectrics, with the idea that, like, you can have sub-wavelength featured materials which will have unique properties which do not exist in naturally available materials. So these metamaterials have got broad terminology now, where we can design these materials and develop these materials with sub-wavelength features and with properties which we pre-decide. So accordingly, my own work has been to enhance the magneto-optical properties, or studying how these plasmons interact with other plasmons. So for example, if you have a metal dielectric interface, you can have this charge density wave propagating along this interface. So now, can we have interaction of plasmons with other plasmons? So can we control them? So among other things, so these are things which we have been studying. Right. So from application perspective, like, so we looked at this on-chip Yagi-Uda antenna, and more recently we are looking at perfect absorbers and perfect absorber base. I'll cover a couple of these examples before going to metrology part. So the most recent work is on this so-called bound state in continuum, where we have this array of dielectric rods So in which, like, if we replace one set of rods with a smaller diameter rods, half of them, so then the concept which we know in semiconductors as superlattice happens. So the zone folding happens. At the Brillouin zone, so you can fold the band structure. So because of which, like, so you see these very high quality factors, bound state and continuum modes, which are possible, and we showed that such modes are polarization independent, and we can excite with any polarization. So this is a perfect absorber based structure where in this thin 10 nanometer silicon layer, which you see here, the layer structure is so designed such that the thick gold layer doesn't allow any transmission, and the layer structure on the top is designed such that almost all 99.98% light which is incident is going to get absorbed within this 10 nanometer thick silicon layer. At this particular resonance, the resonant wavelength at which this perfect absorption happens, you also see a very sharp jump in the phase. Right? So this sharp phase jump is what we utilized and showed that we can get this reusable biosensor, and we showed it for 3 different biomolecules in our recent work. Right. So another work which we did is on towards this directional single photon emitters. If you want to go towards quantum key distribution, high security communication and all that, so single photon sources are important. So you need to have a photon when you want it, like when we switch on, so we need to get one photon out. Right. So these kind of sources are still not available, and lots of groups are working on this. So one of the ideas is like we use this nanoparticle as a emitter, and by putting it in a anisotropic material, which is designed such that it's metallic, it's metal-like in the plane in X and Y directions. But if you look at the Z direction, it acts like a insulator. So it's metallic in plane and dielectric in the vertical direction. So we have an antenna on top, patch antenna, and then what we see is that, like, we can get very directional emission. So the direction can be controlled by the design. And we showed 200 times enhancement in emission from single nanoparticles which are under these antennas, and we could get 40% collection efficiency from this single dot. If we have a homogeneous medium of, say, for example, titanium dioxide, we'll see that the emission is in all directions, but the structure makes this emission to come in particular directions in this case. So I'll go it's called the Goose and Hansen. There is a spelling mistake here, is GWOS. So Goose and Hansen. So they have discovered in 1947 that if we have an interface, a rarer to denser medium, a high refractive index and low refractive index medium, and then when light comes and falls, so what you see is the reflected light doesn't come from the point where the light hits the surface, but there is a small shift in the beam position. The center of the beam is slightly shifted. Right. So this shift is named after them because they discovered it. So this is called the Goose-Hansen shift. It depends on the polarization of the incident. Right? They did these measurements in multiple reflections, but the idea challenge is, can we do it single reflection? Can we measure it directly? Right? So what is the origin of this Goose-Hansen shift? If you look at 2 electric fields, and then you just write plane waves and then find the interference pattern because of them, you see this interference pattern which is plotted here as a function of position, and intensity is plotted. So you see that they have some peak at x equal to 0 or the position equal to 0. But if we introduce a phase difference between the first wave and the second wave, what you see is that the center of the interference pattern is slightly shifted. So the phase difference between the 2 waves is causing a slight shift in your interference pattern. Right? So similarly, if you have a plane wave which is incident on an interface, a circular spot, for example, so when it is coming and falling, from one edge to the other edge of the beam, if there is a slight accumulation of phase, slight phase shift is there, that leads to shift in the centroid of the beam. So if we have normal incidence, the spot looks still circular. But if it is coming at an angle, so the circular spot, when it falls, it gets little elongated, becomes a little elliptical. So you have different path lengths, an additional path length which is coming from one end to the other end of the spot. So that leads to this shift, apparent shift in the center of the beam position. So that is the Gauss-Einstein shift. So typically, we don't have to worry about this because these shifts are of the order of lambda by 10. So that is, if we take 600 nanometer red light, so the shifts are typically of the order of like 60 nanometer or smaller. To measure these directly, so we developed a technique where we start with a laser, we make it circularly polarized, we split it into two orthogonal linearly polarized light components. We mix them together and pass them through a polarization maintaining fiber so that the mode purity is maintained. So then these two fall linearly on the sample. And the trick which we do is, instead of measuring on a single shot on a quadrant photodiode, we scan the QPD. So what we're doing is, a quadrant photodiode has four quadrants, four photodiode regions, which are separated by a dead region in between. So when the spot falls exactly on the center of the four quadrants, so then what you see is you get ideally zero voltage out of it. But there is no zero voltage as far as electronic signals are concerned, because there is always some instrument response which creeps in, which is like, say, microvolts or nanovolts or whatever, depending on the structure. So there is never a zero exactly which is possible, 0 volts which is possible to be measured. So the trick which we do is, like, we scan this beam across two diodes, so that you get this knife edge like experiment. So from initially all the spot is on A, and when you move it, like, so eventually it goes to B. So you measure A minus B, so you get a profile like this. So in this, you take this linear part, and then we fit a straight line and then interpolate to get the zero intersection point or the zero voltage point very, very accurately. By using this technique, we showed that we can go to about 50 nanometer resolution, less than 100 nanometer resolution. We could measure 50 nanometer beam shift on plain simple metal film. Right. So the point, at this point, I would like to say that, like, so we all need precision measurement, and purity of the materials is also of concern for all of us in our lives. At some point or other, we will need this, we do need this. Right. So if you look at that, for example, when you talk about precision, if you look at this cave in a hillock, there is not much precision here. So there is a hill and which a hole is made so that possibly a cave dweller was living here. Right? So there is not much precision. But if you look at these caves, this is from the same area. Here you see that, like, you have two layers of caves. There is a ground floor and an upper floor. And most of these caves have almost of similar openings, similar dimensions. And then you have this upper layer where these pillars are equidistant, and it looks like the pillars are also of similar dimensions. Not much impressive until we say that these are built 2000 years ago. So this is from Udaygiri caves in Odisha. So this is the Rani Gufa, built around 1st century BC. That's around 2020 years ago. Right? So if you're still not impressed, so to make these precise or relatively precise structures, there must be some tools which were used to standardize the construction. Right? If you're not impressed with this, if we go 1000 years forward, so this is from Nalanda. This is around between 7 BC and 1200 CE. So these were built. So these are impressive because these shapes are very, very well defined. And you have multiple layers of structures, nice stairs and all that. But the interesting thing is, if you zoom in one of this corner of it and look at it, the bricks are all of same dimensions. Right? So there must be some precision, some control, quality control was there 1000 to 2000 years ago from the known architecture which we have in the country. So if you look at the units of measurements in ancient India, the time is very, very well defined. So this goes to say down to tens of microseconds, or actually less than microsecond, the Thruti, and then goes all the way up to 10 power 22 seconds, which is the origin of universe. So for the length, so this is something from a Harappan excavation site. This is on a shell. So these are very nice, well-defined lines or markings which are made. It's a ruler or a scale, which is used for measuring lengths. And we also know that like we have pretty big, well-defined weights which are possible. When we talk about weights, so Kautilya described 16 different types of balances in his book Arthashastra. Right. So during Mauryan period, we all learned in our history books that like there was state control of weights and measures, and they were controlled by the government. Right. So this is an image of a steel yard or a single pan balance. The concept here is that the weight times the length on this arm is equal to the weight times length of this arm. So you can, by putting a known weight here, so by letting it tilt, you can estimate like, so what is the, you can measure what is the weight of the unknown weight. So this somehow, though was available around the same 1 BC area, the Rome also had, so this is called the Roman balance also. Right. So the interesting thing is that like, so these are all very well defined, like, so what should be the length of each arm, what should be the weight, everything is very nicely defined by Kautilya. Right. There are also other literature which is available which said that during this period we could weigh from say 50 milligrams or to up to 1 ton weights using our balances. These are equal arm balances which were available at that time. So we had pretty good knowledge of weights and balances, lengths and measurements, as well as time measurements. Right. So not just us. If you look at the Egyptian Cubit Rod, so this is like a scale. So you have fingers. So 4 fingers constitute a palm. And this Cubit Rod, which is from a museum in France. So you see at this end, 1 finger is divided into 2 parts. Then here it's divided into 3 parts. And it goes on, like, so very, very fine divisions are available here. So the length measurement is pretty much well known for at least 2000 years. Okay. Then, I don't know if I may call it like, so did we have anarchy? Different regions had different units. Even within a country or kingdom, there was hardly any uniformity. We started measuring with arms and lengths and body height and all these things, right? So even now, many places like we measure the flowers with with the hand, like the cubit, right? So this is well known. And in the modern times, around 1800, the French developed the first decimal system. So this was the meter convention started, and the origin of international system of units started. So the length meter is defined in the early 1800s as it's basically that the diameter of Earth is about 40,000 kilometers. So if you measure 1 quadrant of it, the quadrant is defined as that it connects the North Pole to the equator. Sorry. North Pole to the equator, and that will be about roughly 10,000 kilometers. So that distance divided by 10 power 7 will give you 1 meter. But then the complexity of measuring this length is humongous. So we needed to have a more easier way or a more practical way of length scale. Right? And the kilogram is defined as 1 cubic decimeter of water. Right? So the meter convention evolved, and in 1875, 17 countries signed this meter convention in Paris. So the BIPM, as we know now, was established. So then international prototypes of the meter and kilogram and also the second were formed. These 3 were the first international SI units. Then 1954, ampere, Kelvin, and candela were added, followed by mole in 1971. Right. So the way the whole game of metrology works is you have the BIPM, where you have this international prototype per say kilogram per mass. So then these were made into replicas, and each replica was given to this National Metrology Institute. For example, for India, NPL India is the National Metrology Institute. NIST is in US, and NPL UK is for UK. PTB in Germany, and similar for most of the countries have. Now, the responsibility of NMI is to disseminate it down the line. So, for example, we have these regional reference standard laboratories where the replicas are made like this and given to them. Then they in turn disseminate further down the line to shopkeepers and others. Right. So in India, the metrology began roughly around 1946 when the ISI, and which is now called the Bureau of Indian Standards, was set up. Then NPL was set up in 1947. So the idea is to provide traceability to national standards and ensure that national standards are traceable to international standards. So the law of weights and measures, and eventually, so we became part of the founding member of Asia Pacific Metrology Program. So I'll tell you what this is about shortly. So then we went on to make what is now known as the NABL in 1982, the Quality Council of India in 1998. So then we conducted the first peer review, second peer review, and we are accepted. Our standards are accepted, started getting accepted as international standards. Right? So this year we are celebrating our 75th year. So NPL provides this apex level calibrations to the nation, which leads to standardization of industrial products as one outcome. The status of units which we have at NPL are length we can measure with up to picometer kind of uncertainty. Mass we have close to nanogram. Then time we have about 2.8 nanosecond right now. The electric current and all these so that we have pretty good measurement capabilities with very low uncertainties at par with most of the international community. So the way, just to say that this traceability chain works is so you are at the ground level, industry, laboratories, commerce, and community. So they use these working standards, which are available at, whatever is there in this lower level where the common public level. So these are all calibrated against the working standards in accredited laboratories, which get their calibrations done by the primary standards, which are again traceable to the national standards at NMI, which is NPL. And then NPL in turn are all traceable to the SA units at the BAPM or international level. Right. So we have this Treaty of Meter Convention, so the CGPM. Then we have this International Committee for Weights and Measures, CIPM, under which we have these working groups. These consultative committees or working groups will decide so how we define different standards and how to set up these and make them available. So all these are done at these working groups. So then these are all reported to the BAPM. Then we have BAPM, or geographically this is divided into 6 regions. So we are part of this Asia Pacific Metrology Program. So India is part of the APMP region. All the entire world is divided into 6 different colors representing different regions in the world. Right. So if we say that our country, India, has one measurement capability, say one calibration and measurement capability, which we call the CMC. The process which goes on is so if you claim that we have a CMC for measuring 1 meter very accurately, how do we establish that? So that depends on basically whoever has developed, for example, the NMIs, they submit their first stage review to the Regional Metrology Organization, which is APMP in our case. So then they will review that. APMP reviews this and says that okay, this looks okay. Then there is a second stage inter-regional peer review process which happens. And after successful peer review of this, so these that particular CMC is published in the KCDB, which is the master database, which is in the CIPM. Right. So this whole process takes pretty long time, of the order of like few years at times. So the standard process, setting up standards or making them available for the country is not a simple job of setting up an experiment, but then you need to establish that whatever it is acceptable to the international community. So the role of CSIR-NPL is as an NMI, we interact with the BIPM and all the technical groups and working groups. Then we are signatory of the Meter Convention. So defining and realization of SI units, setting up these standards in the country, then participating in the intercomparison tests and making them competitive at the international level, and register these things with BIPM, then go on to make these available for the national use. Okay. So currently we have about 236 CMCs compared to the leaders. Like, so we have to grow these. So that requires a lot of resources. So we are putting our effort to increase the CMCs currently. So once we have the CMCs, so we have these 4 different groups in NPL. So the main frontal phase of where we interact with the industry is through this CFCT and the business development group. The Center for Calibration and Testing Facility provides all the calibration and testing facilities for the industry and accredited labs. So we also take industry projects through our business development groups. So this is a planning and monitoring group, and the human resource development, where the skill development, basically the government's vision is implemented through different channels, like so interaction with MSMEs. So all these things are taken up by these 4 services which we offer. Right. So the NPL itself is divided into 6 technical divisions, doing all kinds of metrology work, as well as some basic science research which goes on. So which is for futuristic metrology applications. Right. So we have pretty good reach to various sectors, covering government to the private sector to even SAARC nations, as Dr. Bhatt was saying in his opening remarks. Right. So to various industries, it's plotted here. So how we interact with various industries. So most of our interaction directly goes to the testing laboratories. These are NABL accredited labs. So we also cater to strategic sectors like defense. So this is state-wise penetration of metrological services in India. So what you see is there are some countries, some states and union territories where there is literally zero penetration, which also reflects as poor industrial growth in these areas. Right. So now going to the new definitions, the problem with the old definition is, for example, if you have a kilogram, which is a mass, which is known as the International Prototype of Kilogram, IPK, which is preserved in Paris. So the copies were made and given to each of the NMIs, and our copy, which came in 1957, is called the NPK 57. And so we need to carry out like the comparison of this prototype with respect to the IPK in regular intervals to make sure that there is not much variation in the weight of this NPK 57. But what it has been found is like even the 6 replicas which were made of the IPK are showing fluctuation in weight over the years. So this is the fluctuation over the years for NPK 57 itself. So the variation is of the order of like micrograms, varying from 16 to 54 micrograms. So it's not standard, so nobody really understands like why this fluctuation is happening. But there is a fluctuation in the weight, so which will creep into the actual weights which we measure within the country. So we needed definition of these units which are time invariant and not dependent on some replica. Right. So yeah, that's what the primary standard should be time invariant, and kilogram should be defined in terms of universal constant. Then came the fundamental constants. In terms of these fundamental constants of, say, for example, the the Planck constant, or the hyperfine transition of cesium atoms, right? Avogadro constant, luminous efficacy. So all these things have very fixed numerical values. So in terms of these numerical constants, fundamental constants, so the base units of international system SI base units are defined as 7: the time, length, mass, electric current, the temperature, amount of substance, and luminous intensity. Right? So the new definitions are: the second is related to the transition between cesium atom ground state to the excited state. So the hyperfine transition frequency, which is given by this number here. So 1 second is basically this constant divided by delta nu Cs. Right? And the meter is defined as how much time the length given in 1 second, like, so how much time, sorry, because we know speed of light, so we know how much distance light travels in a given time. So the meter is defined in terms of the speed of light. Right? The kilogram is related to the Planck's constant, and ampere is related to the electron charge, Kelvin is related to the Boltzmann constant, and the mole to the Avogadro number. And these are defined. And now with this new definition, so the idea is to set up these experiments and make sure that we have SI units within the country where we don't need to go and compare it with some master every now and then. Right? So this is one picture which is taken on 26th September this year. So here we have our DG, Director General Dr. Shekhar Mande with his wife. The important thing is at the top, what you see is the time. So this is the NPL main entrance, main building. So what you see on the top is the time. So the time, as Dr. Bhatt said, like, so we are the timekeepers, or we keep the Indian Standard Time. So the idea here is to measure the time. So we measure the frequency difference, or the energy separation, h nu, between the ground state and the excited state of an atom, cesium atom or an ion. And because these are very well-defined energy levels with little fluctuation, so you have very sharp resonances. So this frequency is well-defined with very narrow line widths. So this defines very precise time, because 1 over frequency is the time. Right? So we have a fountain where you have a magneto-optical trap in which, like, so you send you release these atoms to go up in the sky through a magnet, and then through a cavity, microwave cavity. So and you basically measure current, optimize the current going through, for example, the excited state population. So the signal coming because of the excited state atoms is what is measured, is optimized, and that will be maximum when your microwave RF frequency, which is driving, matches with the separation here, the nu or the h nu here, right? So that's the idea of what we do. So there is a either an RF or in the case of atomic traps, we talk about lasers. Right? So nowadays people are looking at for higher efficiency or higher lower uncertainty and higher precision. People are looking at these single ion traps for future. Right? So at NPL India, like, so we looking at this 171 ytterbium ions. So the idea of setting up this is to have a ultra high vacuum cavity, UHV cavity, which is driven by a RF power to have this so-called Paul trap, which can keep an ion or an atom within its potential. So then an oven basically is used to heat the atoms and then launch them into the cavity. So you prepare these cavity atoms to be to excite them, so laser cool them and photoionize them using two different wavelengths, 399 nanometer and 369 nanometer. Then you have these repump lasers to confinement to cooling cycle, to image these single ion and use the clock laser, which is basically matching with the transition frequency between the two ground and the excited state. Right. So in this, like, so total 5 lasers are used, and all needs to be frequency stabilized. So this is how a chamber at NPL looks like. So this is Dr. Subhashish Panja and Dr. Manoj Das lab. So high vacuum usage. Then you have this for high precision. You need a very high, highly stabilized and narrow line width laser is needed. So typically people use these external cavity lasers for this. So there's one laser. So this work is going on. And for meter realization, so we have an iodine frequency stabilized helium neon laser. So this is used for making the interferometer, and that interferometer is used for length standard. So in the kilogram, as I mentioned, so it is kilogram is defined in terms of the Planck's constant. So to measure this, there are two different techniques. The one which is currently available at NPL is a prototype of the so-called Kibble balance. So here you have a mass in one arm of the weighing balance, one pan, and in the other arm, you put a magnetic coil and you apply a current to it. So the current will induce a magnetic field, which results in a Lorentz force. So by controlling the current, so we can balance the two arms. So because we'll know then the current, so we will know basically the force due to gravity mg is balanced by ILB in this case, right? So but then I is the current which we know, which we can send with precision, and L is the length of the coil, and B is the induced magnetic field. So these two depend on the material of the coil. So to avoid to remove that dependence on material, so what is done is in the dynamic mode, where you basically move the coil in a magnetic field, so because of which there is the induced voltage, induced EMF, which is measured, right? So this is known as the dynamic mode because the coil is moving now, right? So now by equating these two, so the material dependent L and B values are removed, and then you get the you measure the Planck's constant as accurately as possible. So this is a prototype demonstration model, and we are looking at 100-gram demonstration soon. So for society, we take up lots of new projects covering environmental sciences to releasing standard reference materials, PPE kit, calibration facilities. These are all the works which are going on. So eventual idea is to go towards these new quantum standards for current single photon detection and all these things for futuristic things. So we should have all these things in the country so that the dependence on other nations is reduced. Right. So just for the societal applications, I'll show one example. These are slides from Dr. Arun Kant Singh. So this is for biomedical metrology, looking at calibration of defibrillator, then infusion pump, as well as future plans are for the incubators. So we have, to set up anything, so it takes long time. As I want to stress once again, when you want to set up a standard, for example, for defibrillator, so there is a specific pulse shape which needs to be generated, and we have to make sure that like the pulse shape, the profile is maintained, the heights, timings, all these things should be accurately measured for any commercial device before anybody can certify these things, because these are of direct impact to humans. So there is a lot of care which goes on. So you need to measure the uncertainty budget of each and every aspect. So you have a digital oscilloscope. So how much is the uncertainty in the voltage measured? How much is the uncertainty in the time of this? So the multimeter which is used, what is uncertainty in its measurement values? So all these things are taken care before setting up a standard. So eventually, every single equipment is to have traceability to the primary standards, and then we have to publish these things, then make it available for the industry. So Indian reference materials is other aspect where we are working towards for this Atmanirbhar Bharat. So to reduce this foreign exchange outgo, we are continuously increasing the portfolio of these BNDs, or the Bharatiya Nirdeshak Dravya, the Indian reference materials. So these cover from cement industry to precious metals, gold, silver, to like petroleum, chemicals, even food BNDs are also possible. So as a NMI, we have to make the metrology and the metrology standards available for the nation. So this is of utmost requirement for national economic and industrial growth. So the metrology supports development of primary and reference standards and national system of measurements as an NMI. So NMIs, actually NPLI, NPL India in this case, we are responsible for the apex level metrology in India. Just to summarize, so we are mandated to be the National Metrology Institute of India by an Act of Parliament. As an apex lab for standards in the country, we work on setting up, maintaining, and disseminating standards across the country. We actively participate, involve ourselves in BIS, QCI, NABL, NABH, among others, so that we are also involved in the policy making and policy implementation. Right. So this is our CFCT, through which we make these things available to the industry and NABL accredited labs. So thank you.
Thank you so much, sir, for your such an illuminating and enriching lecture. During this talk, Professor Venu Gopal started with the materials and their categorization, metamaterials, plasmonics, reusable sensor design, directional single photon emitters, whose ancient shift and its measurement. The areas where metrology is very crucial in terms of quality of the measurement. He comprehensively covered about every aspect of metrology, including historical background, SI units, meter convention, signatories and member countries, traceability pyramid, unbroken chain of measurements, various regional and international bodies, NMI, calibration and measurement capabilities, certified reference materials or BNDs or Bharatiya Nirdeshak Dravyas, redefinition of SI system of units in terms of the fundamental constants and its requirement. Professor Venu Gopal also mentioned about India's scenarios on metrology, quality infrastructure, and role of various bodies for ensuring the same. He specifically highlighted NPL's missions and achievements with specific examples from our every area and walks of life. Sir, from your lecture, we realize metrology has a vital role to play, whether it's in national scientific or economic growth, healthcare infrastructure, barrier-free trade, combating pollution or climate change, or meeting the UN sustainable goals. Everywhere, metrology is very crucial. We understand that being the NMI of India, through unbroken chain of measurement capabilities, calibration and test abilities, BNDs developments, certification courses, training programs, and outreach activities, NPL is serving the nation by strengthening the quality infrastructure in the country. Sir, we are greatly benefited and enriched from your talk and more determined to take the metrology further under your able guidance. We thank you once again for sparing time from your extremely busy schedule and delivering this talk. Now I request Dr. Vikas Srivastava and Roshan Agarwal ji for taking over the process of online release of the Swadeshi Vigyan Patrika. Thank you.
Thank you, Dr. Praveen Saini. I've been assignment for release of Swadeshi Vigyan Patrika. Let's brief about the Patrika first. We are on the process of release of third issue of Swadeshi Vigyan Patrika, and its theme is health, mental and physical relationship. It was a long exercise, and this issue comprises 14 articles in 4 languages and 2 short communications. And language covered Hindi, English, Sanskrit and Malayalam. And I must mention that coverage of articles are from Kashmir to Kerala and Rajasthan to Jharkhand. It's a wide circulation, and we received articles from renowned personalities from IITs, CSIR, and various reputed universities from different part of country. And in this issue, we got the articles from Ayurveda, environment, yoga and meditation, Vedic Krishi, and other aspects of the society. We are in the process of issuing this fourth issue very soon, somewhere in last of the December or in the month of the January. Since main objective of publishing Swadeshi Vigyan Patrika is to provide a platform for researchers and uh, and in this process we are also in the process of releasing a special issue especially for the students of PG, and very soon I think in this month we may release this issue. And for release I acknowledge to all the editorial board members and concerns who contributed for release of this issue in particular, and Dr. Bhatt as patron and Dr. for and guidance. It is a Ramasami and Professor Dr. T. Ramaswamy, I would like to read out few words, though I don't feel myself as competent to say anything about Dr. T. Ramaswamy since he is very renowned personality. But as the customary and system of the release, I would like to read out few words for Dr. T. Ramaswamy before release. Dr. T. Ramaswamy is former Indian Science and Technology Secretary, and prior to this, he has served as Director, Central Leather Research Institute, Chennai. Dr. T. Ramaswamy obtained his Bachelor's and Master of Technology in the Leather Technology from the University of Madras in 1969 and 72 respectively, with first rank, and Doctor of Philosophy from University of Leeds, United Kingdom in January 1976. Dr. Ramaswamy carried out postdoctoral research in energy at during 1978 to 19. Dr. Ramaswamy holds 37 patents, out of which 14 have been commercialized, and he authored more than 2 publications and 8 book chapters in reputed journals and publishers. Apart from this, he authored numerous journal articles in magazines and newspapers, etc. Uh, he has been awarded various awards. List is so long, but due to time constraint, I will read few major awards conferred to him. Padma Bhushan Award in 2014. We all know it is a great award. Padma Shri in 2001. Shanti Swarup Bhatnagar Award in 1993, which is the highest award in the field of science and technology in India. Coleman Research Prize 1976. Vasik Prize for Environment Technology 2001. Vasik Prize for Chemical Science 1990. Dr. Y. Naidu Amma Memorial Award 2018. Dr. T. Ramasamy is a fellow of Indian National Science Academy, Indian Institution of Chemical Engineers, and Third World Academy of Science. Now I request Dr. T. Ramasamy to please release the third issue of Swadeshi Vigyan Patrika in presence of Professor Venu Gopal Achanta, and I request Sri Roshan Agrawal ji for further proceeding of release.
I am sharing the online Swadeshi Vigyan Patrika, and the link of this Swadeshi Vigyan Patrika is available on our website also. So here is our link for Ramasamy ji.
What do? I just say I release, because it's better that you control yourself. Okay.
Yes, sir. Yes, sir. Yes. Sir.
And I'll take the pride of saying I release, but let me request Roshan to do the rest.
But this is our magazine. And,
okay. Because you see, the online things are better to control from one place.
Yes, yes, sir. Yes, sir. So here we have all the here our members are there.
Yes, in there. Sure.
Okay, so here is a small forward from your.
Don't worry. That don't worry about.
Yeah, yeah. And here we have different articles are there, like Sanskrit and Sanskrit or Gyan ek Anupam Sangam. And this is article from our Ashutosh ji, who has done the Mangala Ashram. Then there is green and low cost technology for arsenic removal to produce drinking water. Article is there. आयुर्वेद और में शारीरिक और मानसिक स्वास्थ्य, ये डॉक्टर. So we have, this is our bilingual magazine, as Shri Vikas ji has told us. Yoga through Sahaj meditation, unique tool for total care. Then this is the article in Sanskrit, and Ashutosh ji, can you give some? This article.
My request is you have it released.
Yes.
There, and it's because of an online process.
Yes.
I think it's better that you release it to as many people and let them read it, because
yes.
It would be very inappropriate on our part to pretend we are multilingual.
Yes, sir.
Okay?
Yes, sir.
And what I'll do, for the sake of completion,
yes, sir.
Then my request to you is to have this distributed widely to the people who wish to read them.
Yes, sir.
And since Dr. Bhatt sent me this earlier,
yes,
I read out the articles which I could read in the language I understand.
Yes, sir.
I'm sure that others will have.
Yes.
So
sir.
my request is, I'll probably take 5 minutes and then express my goodwill for all of you.
Yes.
Then
sir.
we can continue the program, because it's in terms of planning is easier. Roshan, is that okay?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir.
Let me say, I'm delighted to be among the family of CSIR chaps. And I see Dr. Venu Gopal Achanta, who has joined the family more recently as a CSIR. And I see lots of old friends of mine. Both Dr. Bhatt and I have aged together, have grown together. And this is not him alone. I see here in the list, BK, and I thought I suddenly in my own family. Therefore, I'm thankful to the SSM'D for giving me this opportunity to be among my own family members. My very dear family members, brothers, sisters, now I'm old enough to say daughters, sons, grandchildren, because that's a kind of a number I have. Let me say that people like me have been with this in terms of an emotional connect to the Swadeshi Vigyan Patrika as a part of the movement. So I'm a particle in that big movement that has been happening. And as was told by Dr. Bhatt, I am one of the very early fellows of this academy, this body myself. And I'm particularly for a country like India, you talk about Upanishad, okay? It has Annamaya, Pranamaya, Manomaya, Vigyanmaya, Anandamaya. What it tells you, Vigyan was something which is part of an evolution of mind towards bliss. We are talking about science for filling our bellies. We are talking about science. When you talk about science, we are talking about something material. But I think the bliss is really an aspect of eternal bliss. And that's how, for a society like ours, which talked about in the Upanishad, Vigyan Maya as a tool to Anandamaya. I think the science in this country has a roots far, far ahead of the 17th century revolution that happened, and the 17th century science. It's a pre-Newton. The Vigyan in this country is pre-Newton, and therefore to talk about Swadeshi science movement itself is an interesting facet, because so the science was Swadeshi in this country. So we have been part of that big movement, and that's the reason why when I see Dr. Bhatt with a lot of beard and a lot of energy is grown, and he brought this up very early on. I'm very happy today that we are now at the verge of talking about something very fundamental. It is not for the movement of talking about Indian science. Science is global. Nobody will ever say science has a geographical boundary. Science is global. And Vigyan is not even global, it is universal. Therefore, we talk about Vigyan in a different time scale. For those of us who know that the first person who said nothing leaves the universe, energy is converted to matter, matter is converted to energy, is Gautama Buddha. You're talking about pre-Christ time. Therefore, for this country, the idea of the spiritually leaned learnings in this country, our Vigyan came from spiritual leanings. The modern science came from technology in terms of applications of science. Therefore, what we are talking about in this movement is create a fusion between the science that we talk about as modern, post-Newton time, and the pre-Newton spirituality systems. In fact, in the Indian civilization, Indian constitution talks about scientific temper. I don't think any other constitution in the world talked about scientific temper. Section 51A. And if you go back and ask, where does scientific temper come from in the constitution, you'll trace it to Buddha. Because the Buddha had said, don't believe me, you trust me, you only accept what is rational. Therefore, this question of having this Swadeshi Vigyan Patrika is essentially to say the language cannot be a barrier. Because somehow we seem to think the English is the mother of science, but actually English is a mode of communicating science. Therefore, we must understand the science has much greater root in this country. And when we have this kind of a movement, Swadeshi science movement, it is to bring forth to a society and young people that we do not have to think that all the knowledge came from the Western world. It turns out, if you go back and look at some of those, it doesn't matter whether you believe it or not, there's supposed to be a statement made by General Macaulay, probably said that never made. What it says is in 1750, 1735 February, that he visited this place, spread around the country, and found there's no beggar, no thief, and there was no poverty. And he said that the reason is the education is based on spiritualism. And unless we change the educational system and alter it, we can never colonize. So fundamentally, it said, unless we make an Indian believe that anything that is English is better than their own, we cannot colonize. Fundamentally, the colonialism in science, unfortunately, is the reality. Not reality in this country alone, across the world. Therefore, this kind of a Swadeshi Vigyan Patrika is to say that, look, our roots are strong. And we do not have to keep borrowing, like Rabindranath Tagore's Nobel Prize said, going around children like beggars, moving culture to culture, begging for something. And in this spirit of science movement, Swadeshi science movement, presented in a multilingual format, presented in terms of making science reach more people in a language which is native to them, and the content which connects the context. The science content had to connect the context, and the context of India is pluralistic, multivariant. The standardization is one thing, but it is to read the diversity of this country, we require a different system. And in this context, I'm very pleased that I got an opportunity to be part of this program. When Bhatt invited me to this program, I wanted to be a listener. And at Tlur, not only a listener who was not in the video, just listen from the background. Bhatt is a very clever guy. He believed that the Ramasami is a very dangerous guy if he's hiding behind something. So he put me on the spot and he said, look, you're going to release this. And it so happened, as was told by Dr. Bhatt, he chose 4th December, and primarily he conveyed that he didn't choose the 4th December. Okay? 4th December was chosen by forces much larger than all of us. He used the word godly. I think all of us in science must realize we did not choose science. Science chose us. Science chose us to be the agent of that science. And I think all of us on this gallery who are here, all my great friends, are essentially chosen by science to be agents of science, champions of science. And today, what we have is a science, Swadeshi Vigyan Patrika is truly an act of the agents of science, reaching more people and serving the cause of science. I think the cause of science is much larger than scientists. I must tell you this very honestly, and I'm very delighted that it is happening in NPL. And I understand from Dr. Venu Gopal that the NPL is growing in stature all the time, because I have known NPL for many, many years. And by coincidence, it happened to be the birth anniversary, 123rd anniversary of K.S. Krishnan. And I was happy to see Gopal also in the morning when Ajay Sood was giving the talk. And I am mightily pleased to be a part of this. And I thank the organizers for giving me an opportunity to be a part of this. And I consider this not as a pride, but as my personal opportunity to make an offering to the goddess Saraswati. And I think ultimately what we must understand, any knowledge activity in this country, I think we must bow down at the feet of goddess Saraswati and then say, thank you, we got an opportunity to be a part of this program. I thank you very much. And I really am pleased to say that I am part of the release function. I think that it is not the release because a Patrika is not blocked somewhere. It's not a jail from which we're releasing something. Yeah, we are prisoners released. But I think Jnana can never be bottled. Yeah, forget about science. In no knowledge can be bottled. And the concept of your Western world of intellectual property protection of the infringement is counterintuitive to the traditional wisdom this country talked about. If you look at this difference between IPR and traditional wisdom, one is in terms of the approach was data, documentation, closing, infringement. Those are the kind of system protection systems. But traditional wisdom is sharing. It is not closing. Therefore, all of us can learn through this Vigyan Patrika lot of buried knowledge, hidden knowledge in our social systems. We call them traditional. I am sincerely believing I think we have to go back into the future, because there's a tremendous amount of traditional wisdom for preservation, biodiversity, and a kind of traditional wisdom. And this particular approach is to connect the modern science with the traditional knowledge that this country provided. And I'm very pleased that several of my family members have joined. I thank Bhatt, I thank Gopal, I thank every one of you. I see VK here, and VK Gupta has been my let me say, friend in the CSIR system. Hey, Gopal, when we were in CSIR, there used to be 40 laboratories. And therefore, DG used to be called Alibaba. And all of us were called Charles Chore. Okay? And in that Charles Chore, I see some today. And VK, remember the digital library that he talked about, TKDL. And I'm very happy that we have all this kind of knowledge base. I thank you very much. Wonderful, great opportunity. Thank you very much.
So thank you, Ramasami, and we applause, a big hand, we clap to you. Thank you. So now I'll call, as we are proceeding with the ending of the program, now I'll call Rashmi ma'am, who is basically behind this whole project of Swadeshi Vigyan Patrika. Rashmi ma'am, are you there?
हाँ जी, मैं हूँ यहाँ.
Yes ma'am. You may continue ma'am.
जी, नमस्कार. मैं आप सभी को बहुत बहुत आभार प्रदान करती हूँ. मुझे बहुत खुशी है कि आज हमारे बीच में डॉक्टर टी रामासामी, डॉक्टर वेणु गोपाल अचंता और बहुत सारे वैज्ञानिक इस मंच से जुड़े हैं. आज हमें डॉक्टर वेणु गोपाल के द्वारा जो सुनने समझने को मिला है, कितना उन्होंने बहुत सरल भाषा में हमें यूनिट्स की डेवलपमेंट की हिस्ट्री को बताया. उन्होंने बहुत सारे क्यों इनकी आवश्यकता है हमारे जीवन में, किस प्रकार से हम जो न्यूमेरिकल और फंडामेंटल कांस्टेंट्स के ऊपर हम इनको डिपेंड करें बजाय हम किसी भी मटेरियल के ऊपर डिपेंड होने से, और किस प्रकार से वो जो हमारा एनपीएल है वह काम कर रहा है इस दिशा में. एनएमआई की जो सर्विसेज हमारे नेशन के लिए इंटरनेशनल स्टैंडर्ड्स को मीट आउट करने के लिए आवश्यक है, और कितना गहनता से हमारे सारे वैज्ञानिक इस दिशा में काम कर रहे हैं और समाज के लिए इनकी क्या उपयोगिता है. बहुत सरल भाषा में आज आपने हम सभी लोगों को आपके द्वारा किए गए कार्यों से अवगत कराया. मैं आपकी बहुत बहुत आभारी हूँ. डॉक्टर रामासामी ने जो रिलीज किया है हमारा यह 3rd संस्करण, जिसमें एक छोटा सा प्रयास है कि भारत के, जैसा अभी सर ने कहा, कि जो हमारे मौलिक चिंतन है, जो हमारी पारंपरिक विरासत है, जो हमारा ज्ञान है, जो हमारा विज्ञान है, जो हमें परंपराओं में मिला है, जो हमारे इतिहास में हमें बताता है कि हम क्या थे, तो एक आत्मविश्वास को पुनर्जीवित करने की ओर हमें जाना है. और इसी मंशा से यह एक प्लेटफॉर्म शुरू किया गया, जिसमें एक प्रयास है कि सभी वैज्ञानिक अपना मौलिक शोध और अपना मौलिक चिंतन, जो हम कहीं इंटरनेशनल जर्नल में या कहीं और प्रकाशित नहीं कर सकते, वह सभी विचार इस मंच पर आमंत्रित हैं. और बहुत हम लोगों का आप सभी से इसमें सहयोग करने के लिए एक अपेक्षा है कि सभी वैज्ञानिक अपने जो छात्र छात्राएं हैं, जो भी मौलिक चिंतक हैं, जो एक नई दिशा में मॉडर्न साइंसेस को हमारे एंशिएंट साइंसेस से जोड़ते हुए सोसाइटी जो हमारे समझ में आसानी से आ सके, अलग अलग भाषाओं में उनके द्वारा जो भी सहयोग हमें प्रदान किया जाए उसको एक मंच पर प्रकाशित करने के लिए संकलन करने की दिशा में हम लोग प्रयासरत हैं. आज मैं बहुत आभार प्रदर्शित करती हूँ उन सभी लोगों का जिन्होंने इस मंच पर अपना समय प्रदान किया. एक बार पुनः सभी का आभार. नमस्कार.
now we are in the end of the program, and हमारा national anthem, we used to play national anthem in the end of the program. So I request all of you to play, please stand or as a respect national anthem. Thank you. जनगण मन अधिनायक जय हे भारत भाग्य विधाता जय पंजाब सिंध गुजरात मराठा रावण हिंद हिमाचल
गाथा जनगण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय 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 हे
भारत माता की जय।
धन्यवाद।
बहुत बहुत धन्यवाद सबको।
Thank you, sir.
Thank you, sir. Sir, thank you very much. I will accept only one thing from Dr. Ramasami sir today.
What?
That he called me as a clever guy. I accept that. And having accepted that, kindly allow me to say two things now, because that will certainly endorse that I am clever. See, there is a phrase, small is beautiful. Today, I will not say it is a big program. It's a very, very small program. Normally, there should have been two independent programs. The kind of personalities we had today, first time we made it very small. Otherwise, it would have been two different programs. But I would propose to the organizers or the editorial board members, being a clever guy, as Dr. Ramasami sir said, see, it's possible to have a 3 days workshop, or you call it a seminar, where you can invite all these authors who contribute, because people don't have time to read. People don't have time to read what we write. That's what I personally believe. So better to have a 3 days workshop or 2 days workshop where all these 3 magazines which we have published during the Corona time, let there be a debate and deliberation and lecturing and all that. So you can do physical way also, but I am afraid in the Corona time one can do that. It can be done online also. So that's how, thanks to Dr. Ramasami sir, he called me clever, and that cleverness prompted me to now prompt you all to organize another workshop where you can club all these 3 magazines and hold some workshop of 2 days or 3 days. Thank you very much. And I would also thank Professor Ananta Venu Gopal ji for his kind gesture, for his kind acceptance of our request to deliver a talk. As Dr. Rasmiji said, he said everything in a very simple manner, understandable manner by each and everybody. Thank you both. Thank you very much. Thanks everybody. Namaskar.
Thank you. Now I'm ending this meeting. Thank you very much. Thanks for everyone for attending this meeting in a very short time. Thank you very much once again.
Thank you, sir.
Thank you, sir.